Welcome to Mathy. My name is Dr. Siobhan Curtin. I'm a lecturer at Limerick Institute of Technology. This short video deals with the manipulation of algebraic expressions and equations. So welcome today to this short video on logarithmic equations. And before we get started, there's just a couple of points I'd like you to remember before you look at any log equations. So the very first thing you should always look at when you look at log equations is check that each term has the same base. If this is not the case, it is recommended that you use the change of base rule to change all of them to a common base. If no base is given, then the equation holds true for all bases. Another rule that's particularly handy is the log of b to the base a is equal to the log of c to the base a. Well, then b is equal to c. Another very good one, and it's a good idea to be able to change between the exponential form or the indices form and the log form, is using this particular rule. So the log of b to the base a is equal to k, then b is equal to a to the power of k. So for the last one, check all solutions to make sure they do not produce logs of negative numbers, as these are not defined. So here are the laws of logs. So if, for example, you wish to add logs of both the same base, you just multiply the argument, and the argument in this case is x and y. If you'd like to subtract logs of the same base, in this particular case, you just divide the arguments x and y. So for this particular rule, the log of x to the power of n all to the base a can be written as n times log x to the base a. Remember that the log of a to the base a is always 1, and the log of 1 to the base a is equal to 0. And the final rule, this is your change of base rule. If log x to the base a can be changed into the log of x to the base b divided by the log of a to the base b. So in this particular case, we've changed the base to this exact same base using the change of base rule. So here we're going to work through 3 examples applying some of these logarithmic rules. So for this particular one, solve for x. 3 to the power of x is equal to 6. In this particular case, it's recommended that you take a log to both sides. So the log of 3 to the power of x to the base 10 is equal to the log of 6 to the base 10. Applying the rule where the indices comes down in front of the log, it becomes x by log 3 to the base 10 is equal to log 6 to the base 10. Now in this case, we want to get x on one side of the equation and all the other terms on the other side of the equal to sign. So x is equal to the log of 6 to the base 10 divided by the log of 3 to the base 10. So when we work this out and we get the log of 6 to the base 10, we get 0.778, and the log of 3 to the base 10, we get 0.477. So x is equal to 1.63. So the answer to this particular equation above here is x is equal to 1.63. So for worked example 2, we must evaluate the following to 2 significant figures. So the log of 11 to the base 8 minus the log of 3 to the base 6. And you'll note in both of these cases that the bases are different, so the logs cannot be subtracted. So we're going to take one term at a time, and we're going to apply this rule here. We're going to get them to the same base. So the log of 11 to the base 8 can be rewritten as the log of 11 to the base 10 divided by the log of 8 to the base 10. And using your calculator, you can work out the log of 11 to the base 10 as 1.041 divided by 0.903. So the log of 11 to the base 8 is equal to 1.153. Looking at the other term, the log of 3 to the base 6 can be changed into the log of 3 to the base 10 divided by the log of 6 to the base 10. And this gives you 0.4771 divided by the log of 6 to the base 10, which is equal to 0.7782. So your answer is 0.6131. So therefore, the log of 11 to the base 8 minus the log of 3 to the base 6 can be written down as 1.153 minus 0.6131, so the answer is 0.54. Now for worked example 3. So solve the following equation for x. So the equation is given as the log of x minus 2 to the base 2 plus the log of x to the base 2 is equal to 3. So we must solve the following equation for x. Now, you will note that they're both of these logs have the same base, the log 2, the log of 2 here. So therefore we can apply this particular law. So this is where we want to add both terms. So when we want to add both terms, we've got to multiply the arguments. In this case, we've got to multiply x minus 2 by x. So let's go ahead and do that. So that's the log of 2 by x minus 2 multiplied by x is equal to 3. So working out the brackets, it becomes the log of squared minus 2x to the base 2 is equal to 3. Using our form where we change between exponential to log and log to exponential, we can apply this formula here. We end up as 2 to the power of 3 is equal to x squared minus 2x. So that is x squared minus 2x minus 8 is equal to 0. So we're going to find the factors for this equation, and the factors for this equation are x minus 4 and x plus 2. So x is equal to 4 and x is equal to minus 2. But remember, you must make sure that all of these answers make sense. So if x is equal to minus 2, the equation then becomes the log of minus 2 to the base 2 plus the log of 2 to the minus 2, which is equal to 3. So in this particular case, the log, since the log of minus 2 to the base 2 is undefined, x minus 2 is rejected as an answer. X is equal to 4. I hope you found this video useful. Please check the Matty portal for more information on this topic. Thank you.